Hello everybody, welcome to Blue Marble Science. A couple of days ago, Professor Dave put out a video with 10 simple questions for flat earthers. And our favorite flat earthers didn't waste any time trying to come up with a response. Now their response was, well, let's call it interesting. Warning, severe facial and monitor damage alert is in effect. Get out the oven mitts, push the monitors back out of punching range, and let's light this dumpster fire and have some fun.
Okay, so I would like to ask you, have you seen the latest video from labeled 10 challenges for flat?
No, on general principle, if you use your first name along with your title, I automatically assume you're a moron. So if you call yourself Dr. Phil or Dr. Becky, I'll just think moron, and therefore I don't watch. So no, unfortunately I've not watched.
Yeah.
Especially if you've not earned that
I have
title.
watched it, and I would like to go over it if that's okay.
Sure.
So he starts his video by saying, and I quote, "This will be some basic things that anyone can do to test the validity of the flat Earth hypothesis. These are so mind-numbingly obvious that the fact that you don't do them is an immediate indicator of your complete lack of intellectual." So that's how he
hold on,
starts
just
the
let's
video.
just you have to, if you can you slow down? So we're going to pull this apart as you go through it. So his opener is to offer up a what's it called? Not when you group everyone together, a stereotyping fallacy, and also he claimed hypothesis for flat Earth models. Correct?
Well, no, Nathan, that's not what he said. Let's listen to what he actually said.
Let's call them 10 challenges for flat earthers. These will be some basic things that anyone could do to test the validity of the flat Earth hypothesis. These are so mind-numbingly obvious that the fact that you don't do them is an immediate indicator of your complete lack of intellectual integrity. Let's get started and you'll see what I mean.
So within the first opener, he's got a false dichotomy because he's going to be comparing a model that he's got as a, what was the first one I just said? Stereotyping fallacy. He's decided that all of us hold a model in false dichotomy to his globe model. And he's also incorrectly identified the word hypothesis. Hypothesis being a scientific prediction, which a model isn't. So within the first sentence, I'm glad I don't watch, he's absolutely crippled his own argument by way of 3 fallacies: a stereotyping fallacy, a straw man fallacy, and a false dichotomy.
No, Nathan, what Professor Dave did was not a false dichotomy or a straw man. He never made any mention of a model, and his use of hypothesis is perfectly correct. Look it up in the Oxford Dictionary. It is a supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation. On the other hand, what you're doing at the moment is constructing an enormous straw man, and you're doing that because you know you don't have a single answer for a single question.
And he's declaring in his opening part of this video that he's looking at a hypothesis for flat Earth models.
Yeah. Hypothesis for a model?
Yeah, he's talking about models quite a lot in this video, and this takes me to the first point. So his first challenge is make a real, and he's showing a AE map, of course, and explains how it can't be the real map. So that's a straw man already. So generally, people in the flat Earth community are not claiming that it's the actual map of the flat Earth. It's often used as a representation, and it's a good way of visualizing the flat Earth concept. And it's often used to illustrate the point rather than depict the actual.
Hang on a sec. If you go to Google and just type in all maps are wrong, you will find umpteen references that tell you that all the maps are wrong. Because no matter how you project it, no matter how you describe it, draw it, calculate it, scale it, no matter what you do, you can't get it to be accurate for some reason.
The reason flat maps are wrong, Sloppy, is because you can't wrap a flat map around a sphere, and we live on a sphere. Some flat maps are more accurate than other flat maps. It just depends. Now you guys are claiming you don't have a map. That's all Professor Dave was saying. Make one. Thank you.
Definitely.
Okay, so does that mean I can just skip past number 2 then? Because it's just essentially the same. He's just holding up a straw man in false dichotomy in the form of this reified model he has us tied to with a stereotyping fallacy. So to make this example, he's got 4 fallacies so far. 5 if you include reification itself.
In other words, you can't explain it, so you'll just skip it. You have no way of explaining how Tierra del Fuego could have 17 hours of daylight at the end of December. Nathan, you're 0 for 2.
And then he says, pick a date and time, and then predict an event using only the flat Earth map. And of course, he's showing the A map. So
he's just towing the line. He's just holding up this false dichotomy strawman map model reification fallacy as a stereotyping fallacy, again, for point 3. So it's all based on, you must hold this map that I'm going to burn. Okay.
Yeah.
Same lame excuse. You don't have a map. Well, make a map. Use it to come up with any sort of prediction. Either that or admit to everybody that you've been lying about this from the beginning.
Number 4.
I'll slow you and see it. Say it.
Looks like we're doing this.
Yeah.
We've got 10 minutes left on the live show. Let's rattle our way through them. 10. Number 4.
Yeah. So number 4, yes, and hold on to your seats right now. Show something over land far away. Show us something over land that is 1,000 miles away. Use a telescope and show us Las Vegas from Dallas. What is the problem here?
Okay. Okay, let's just address these quickly. Okay, no worries. He needs to look into angular size resolution limits based on apertures of the camera or optics of the telescope in this example. The telescope has an angular resolution limit. You can calculate this limit with the Rayleigh criteria. Things get smaller as they get further away. At 1,000 miles, things get too small to see. What I would recommend for Professor Dave, go and watch a little excerpt from a series called Father Ted, where it is explained that the toy cow close to you is small, but the cow that's full size in the distance on the hill is merely far away. Now this is called perspective. If you're trying to look at New York from England, it's too small to see. The angle is too limited. Now, given that this guy professes to be a professor, I would think he would understand that things get smaller as you get further away from them. And 1,000 miles is far too far to resolve things. Their angle is too small. So I'll just declare right here, right now, pure stupidity on account of Professor Dave. Do you not understand that things get smaller as they get further away? Oh, I know why he thinks this way. Because his model is based in geometry. And his model would use actual sizes for things in the distance. For example, if you were to ask him how much of whatever the hell this is on the horizon is being obscured, he would tell you in feet and inches or meters how big this item is and how much is blocked. However, these items at 1,000 miles will still be the exact same feet and inches value, precisely as his model calculates for. Now, that would mean his globe model and its mathematics ignores perspective. And because his model of a globe Earth ignores perspective, he expects us to express the same exact fuckwittery and assume that we can see things at 1,000 miles. No, it's only your model that excludes the angle of things getting smaller as they get further away. Why on earth would the failings of your heliocentric model and its complete lack of angular size reduction be somehow transferable onto us as flat earthers being able to see things when you removed the hijacking of this perspective effect, which you've called Earth curve, in your perspective exclusive maths? You complete clown. So, Professor Dave, would you expect the angular resolution to be conforming to seeing things at 1,000 miles? How big would something have to be in angular size to see it at 1,000 miles on any shaped surface? You complete clown. Then, when you've answered all of those questions, explain why the hell your geometric maths excludes perspective, and for some reason completely ignores the fact that these things are very small in the distance. You'll give me their size in feet and inches, won't you? You complete clown. Telling us that you think things stay the same size at any distance because their feet and inches value doesn't change in your globe maths. Yeah, they do. Their angular size, also known as apparent size, gets smaller with distance. Funny coincidence, Professor Dave. People are telling us all about how apparent everything is at the moment, not realising, like you, that their calculations for a sphere-Earth reification fallacy utilises actual sizes rather than apparent sizes. That would be the angular size that gets small as it gets further away. Yeah, this would be a very big angular size if we were right next to it, but you'll still give it in feet and inches and then ask us to justify why we can't see it 1,000 miles.
Here's an observation you should have no trouble making, Nathan. Here's Kansas City. Here's Denver, Colorado, and these are the Rocky Mountains to the west of Denver. That's a distance of about 590 miles. The elevation in Denver is about 1,000 feet. The elevation of the Rockies to the west of Denver is about 13,500 feet. That's 12,500 feet difference. The angular size of the Rocky Mountains to an observer in Kansas City should be about 0.23 degrees. That's roughly half the size of the sun. That should be no problem at all with the naked eye. That is 10 times the Rayleigh criterion for angular size resolution. So why don't you guys do that? Why not show us something like that instead of these highly refracted images of oil platforms? I know why you don't. You can't. Because you can't see the Rocky Mountains from Kansas City. And you can't see them because they're beyond the curve of the Earth.
Your calculator excludes perspective, you complete moron. Should we move on to number 5?
Hang on, before you do, I had somebody on my channel. He sent me a message and he says, Sleeping Warrior, I'll give you £1,000 if you can show me any picture or video of the Mourne Mountains in Northern Ireland from anywhere on the coast of England. Should be piss easy on a flat earth given a clear day. And I thought, Mourne Mountains. Let me go and have a little look at that and see how what the angular size should be. So I looked into it and I realised that it's just too small to see. It's not a big enough mountain. So anyway, I thought, should I respond or should I ignore? But because you've asked a question about the angular size and why you can't see Paris from New York or whatever, because Professor Dave's put it in his video, it directly addresses the point that Nathan's just said, but it puts it with a little bit of maths because they all say, oh, you can't do any maths, Riley. So I thought, right, okay. So here's my response to him. It says, Dear MJH, this is the guy. I said, I've had a little look at this for you. Your claim is, quote, should be piss easy on a flat earth given a clear day, unquote. Assuming an earth with no atmosphere at all, just looking at the geometry in isolation, Sleeve Muck, which is the name of the mountain that's near him, happens to be 674 meters high from sea level. It is 160,934 meters away from the English coast. This gives it an angular size of 0.2 degrees. 0.2 degrees is a random number to you, I'm sure. So let's add something to help to scale it to help you. The longest ground-to-ground line of sight ever photographed is 237 miles from Mount Canigou in the French Pyrenees to the French Alps. Against the background.
Yeah, blah, 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 Anthony. The angular size of the mountain you're talking about over that distance is about 0.24 degrees. The sun has an angular size of about 0.52 degrees. That mountain is about half the size of the sun. You should have no problem whatsoever seeing that with your naked eye. The only reason that you don't want to do this is because you know you can't do this. You can't see that mountain because it's hidden behind the curve of the Earth.
100 miles is within the distance that we can see, and if we assume no atmosphere whatsoever, it is possible. However, because the only one I randomly picked happens to be 674 meters high, it simply is not big enough to see, even with a zoom lens. It's just too small at 0.239 degrees. Obviously, that's compared to 0.7 with the Canigou one. You can find more about perspective if you pay attention to Flat Earth channels. You can find more about the Canigou observation from this link. There are many others documenting this observation with evidence to show you what could be seen and how small it actually is. You can calculate your own angular sizes with this link. You can check your own distances on Google Earth and convert them into the same units using online converters easily. So back to your claim. Should be piss easy on a flat Earth given a clear day. Even without any atmosphere whatsoever, it is simply too small to see because of something called perspective. With an atmosphere, something you can't already seen still cannot be seen. I've explained to you fully why you're wrong, supported it with evidence contrary to your perception, and even done a little bit of maths, so it must be true, right? Will you now admit your claim is simply wrong, and you have no idea whatsoever of perspective? Although it is close enough, it isn't big enough, despite your claim that it is. That's how to deal with a troll.
The angular size of the sun is about 0.52 degrees. By your own calculations, that mountain has an angular size of about 0.24 degrees. That's almost half the size of the sun. How do you clowns figure that's too small to see?
Yes, keep watching the boat. Yes, that one you already, I think, covered in your response. So it's obvious that he hasn't done any research, because he says we should put on YouTube how boats disappear bottom first. And there are, I don't know, thousands of videos of flat earthers doing just that, and he's asking us to do that. So it clearly shows his investigation, I would say.
Okay, so presumably this is a question based on the idea that we have a physical geometric sphere edge for a horizon for these boats to go over and then be blocked from bottom up based on the physical geometry when assuming R, correct?
Yes, and that's where the...
No worries, I just need a yes. So given that he's asking us to keep our eye on the boat and it's going over a physical geometric sphere edge, I'd like to draw his attention to an observation we've dubbed the Black Swan. Now in the Black Swan, the previously claimed to be physical geometric sphere edge is currently being refracted non-geometric, non-physical, according to the fundies who fight here with actual flat earthers who aren't strawmanned by morons using endless fallacies like Professor Dave. So given that he thinks that boat in his imagery is going over a physical geometric sphere edge calculable with an R, they assume, I'd like to know why in the Black Swan image we have a physical geometric horizon that is way beyond the limitations of the geometry laid down by assuming that R value. And therefore all of his cohorts of fundy globe heads are telling us just how non-physical this horizon is, using redundant words like apparent and refracted. So, Professor Dave, is this a non-geometric, non-physical horizon? Or is it the geometric necessity that it must be, based on an R value you assume in your maths that excludes perspective, when you ask us why we can't see things at 1,000 miles? And then when you've wrapped your head around all that, try to explain how we've got a horizon way beyond 9.41 miles, given that the distance to horizon should be about 1.22 miles in the Black Swan images we keep getting over and over again. We've got loads of them now, they're piling up. So we definitely don't have a physical geometric sphere edge for a horizon for boats to go over, so why would we keep watching the boat when all of your cohorts are telling us just how non-physical that horizon is? So try and keep up to date with the Flat Earth debate, Professor Dave. You're claiming a physical geometry that's being denied by your cohorts, you moron!
You've said physical geometric sphere edge a number of times, and that's nothing but a straw man made out of word salad. Physical means of or relating to physics. Geometric means of or relating to the methods of geometry. There's no definition for a sphere edge. Spheres do not have edges. The physical horizon is the one we see when we look out over the ocean. It's the point where the sky appears to touch the water. Using methods of geometry, we could calculate a distance to the horizon without refraction, and we do that in the curve calculators. It's basically useless because the atmosphere always produces refraction. So we have a second calculation which allows for and accounts for the amount of refraction we're seeing. Nathan, this is nothing but a red herring. I think what you're doing is trying to draw attention away from the fact that there's actually a horizon that's visible, and that should not be true on a flat Earth. There should not be a visible horizon, period, on a flat Earth. Would you care to respond to that?
We move on to number 6.
Before you do, Nate, just on the geometric stuff, you set me a bit of homework this week. And can you just pull up the black swan picture first? Because it's just something, geometric consequences again that come from my ears.
I got a better idea. Instead of talking about your black swan, let's talk about this photograph, this one that was made a couple of days after the black swan by the same guy that made the black swan picture. Let's talk about why there is a visible horizon present if the Earth is flat. More importantly, go through Modus Tollens and give us an answer to this. If the Earth is flat P, then the actual horizon, the one we see, has to be behind any visible object, Q. The visible horizon is not behind distant visible objects on a normal day, not Q. Therefore, the Earth is not flat, not P. That's game, set, and match, my friend.
Yes.
Explain
number
sunsets.
6, it says explains. He is stating that a small sun above the flat Earth would simply recede high in the sky and get smaller and smaller until it fades. So clearly here is also perspective. So he thinks that the sun would stay at the same spot in the sky, just get smaller.
Based on his assumptions that he has used when, I keep forgetting that fallacy, when he uses his stereotyping fallacy that suggests a particular size and distance to a sun on a model he's held up in false dichotomy. It's a bit of a mouthful. He says that the sun should do something based on its physicality and distance that we don't know and don't claim here.
So you're going to use the I don't know excuse, huh, Nathan? Well, that's probably a pretty good idea, seeing as how nobody yet has been able to explain how a small local sun can avoid changing angular size as it travels overhead during the day. You're 0 for 6 at this point. You really need to step your game up there, buddy.
Yes. So number 7, it says, say anything about the lunar eclipse. So he's explaining how the lunar eclipse works, and he's showing a drawing, and that somehow is proof that what their claim is actually.
So he's showing a drawing.
Yeah.
Oh, that's good.
So what? Say something about the lunar eclipse. Doesn't it go red?
Yep.
It goes red. There you go. I've said something about the lunar eclipse. I make no claims about it. I've witnessed one and filmed it. It got very, very cold when it went to totality.
It got very, very cold when it went to totality. What? I thought you guys claimed moonlight is cold. Why didn't it get warmer when the cold moonlight went away, Nathan? Holy cow, will you guys please make your mind up? Is the moonlight cold or isn't it? Anthony Riley says it's cold. Maybe you guys ought to talk.
Set up a camera. Oh, we've got this reification strawman stereotyping fallacy on screen again. What a shock. Send a camera up to the sun or moon. I don't know how far it is.
Yeah.
It's based on his assumption that we're using this model. We're not.
So your best answer is, I don't know. Seems to be a pattern developing here, Nathan.
Take some flights.
Yeah,
I used to be an international rep. I've travelled everywhere. You'd struggle to find somewhere I haven't been. Take some flights. Yeah, every single flight I took, what I witnessed on the flights was endless numpties, rows and rows of them with headphones on, listening to a shit series of radio channels and watching crap television that you couldn't really watch with engine noise, or trying to get to sleep, or trying to get drunk, or reading a magazine or book. That's what I witnessed. What I did on my flights when I flew all over the world, undoubtedly flew a lot more than Professor Dave will ever do in his entire lifetime, was I witnessed the flat plane below us. I also witnessed the horizon which was claimed to be a physical sphere edge that should bend at the altitudes I was flying at, never bending, just seeing endless flat plane beneath me. So, if you want to go for a pissing competition, Professor Dave, I've taken a damn sight more flights than you ever will.
Well, Nathan, I'd be willing to bet that I've taken a damn sight more international flights than you have. But that's not the point. So your response is, I didn't see the curve I wasn't supposed to see in the first place. Nathan, that's not what Professor Dave is talking about. Try to find a way on your flat Earth to take a flight from Rio to Johannesburg. Try that one. You're going to need an airplane that can stay in the air for about 20 hours. It doesn't exist.
Right, what's his pièce de résistance then? What's number 10? Do anything scientific at all ever? Didn't we open this with him saying that the model he's going to be comparing should have hypothesis validated for it?
Nope. That's what you said. That is not what he said.
Do something with science. You don't know what science is if you're talking about hypothesis at the beginning of this little presentation. What the hell are you talking about? Tell us what the hypothesis was you were talking about at the beginning of this presentation. Then I'll take you seriously when you mention the word science. Nothing you've done ever to do with this subject, ever, was scientific, Professor Dave. You will not give me any scientific evidence. We've spent the last 6 months asking for a single viable hypothesis from any of the fields of astronomy, cosmology, or astrophysics, and there's none. Science? How dare you? All you have in your heliocentric reification fallacy is pseudoscience. Does anybody have anything to add? I'm going to round out the live show if not.
Yeah, I do.
Good.
There was somebody that did something scientific on this very panel. You got an egg, added a bit of mass to the medium, and it made the egg move. Now, if F equals ma, and the A, the acceleration, was the egg moving, then there must have been a force there. Well, here's the thing, it went the opposite way to what your model would predict, because if I add mass below the egg, that would attract the mass, wouldn't it, on your model? But it didn't do that. It pushed the egg away.
Well, I guess that's about it. Flat Earth obviously cannot deliver a single coherent answer to any of the questions Professor Dave posed. Why does that not surprise me? Hey, thanks for watching. Hope you guys enjoyed it. If you did, please hit that like and subscribe button down there. There's a link to the Patreon. It'll be up in the description. And I guess we'll catch you guys on the next one. Hey, Gladys. We're out of here.